In this topic, we turn ISO IEC 14W1 from a standard into an executable roadmap, connecting governance, architecture, risk, operations, and evidence, so your organization can move with discipline toward audit, management review, and certification readiness. So far, we've built the pieces: ISO 42001 foundations, governance and risk practices, architecture, controls, and operational monitoring. Now the focus shifts from design to execution. We'll connect those pieces into a structured AIMS implementation path that supports evidence, audits, and certification readiness. An AIMS implementation roadmap turns requirements into execution. ISO 42001 obligations, AI risks, architecture decisions, and operational controls are not useful if they remain separate documents. The roadmap connects them into a managed program. It starts with scope, moves through risk assessment and control design, then integrates those controls into real delivery processes. Architecture teams play a central role by creating reusable standards, design gates, and control patterns that teams can apply consistently. The goal is evidence-ready operation, where ownership, milestones, validation, and audit readiness are built into normal enterprise work. Think of AIMS implementation as a lifecycle, not a documentation project. First, initiate and scope. Secure sponsorship. Define the charter, identify AI systems, and set organizational boundaries. Then assess and design. Compare current practices to requirements, evaluate AI risks and impacts, and decide which controls are needed. Next, roll out and operate. Embed policies, lifecycle gates, technical controls, monitoring, and incident response into daily work. Finally, validate and certify. Gather evidence, run internal audits, complete management review, and close gaps before the certification audit. Each phase creates inputs. The next phase depends on. Implementation begins when the AIMS effort becomes a governed program, not just an intent. Start by formalizing the implementation charter, scope, objectives, success measures, and the target certification timeline. Then assign accountable leaders, including the executive sponsor, program lead, AI governance owner, architecture, risk, and evidence roles. With ownership clear, define how decisions are made, how issues escalate, and how work streams report progress. Finally, connect the roadmap to enterprise transformation, AI platform plans, risk management, and compliance priorities, so AIMS is embedded in the business agenda. Scoping answers the essential question: what exactly are we governing? The scope should cover the relevant business units, locations, AI lifecycle activities, platforms, vendors, data flows, and connected operational processes. From there, inventory every AI system using consistent criteria: use case, model type, owner, data sensitivity, risk tier, and lifecycle stage. This inventory becomes core audit evidence. It also prevents blind spots, especially where AI connects to security, privacy, quality, architecture, or vendor management. A good scope is realistic, risk-based, and certifiable. With scope established, the organization turns discovery into a clear baseline. Compare existing governance, architecture, operating practices, and evidence against ISO IEC 14201 requirements and the controls selected earlier. The goal is not only to find weaknesses, but to classify them. Some gaps belong in the management system, some in technical architecture, some in daily processes, and some in audit evidence. Then score maturity and severity using risk, certification importance, effort, and business impact. The result is a remediation backlog with owners, due dates, and clear acceptance criteria. Risk tiering turns assessment into an operating decision point. Each AI system is evaluated against organizational risk criteria, stakeholder impact, legal duties, ethical concerns, and data sensitivity. The resulting tier determines how much governance is required. Low-risk systems may need lighter controls. Higher-risk systems need deeper review, stronger human oversight, more frequent monitoring, and formal approval gates. This is especially important for Gen AI, sensitive data, safety-relevant uses, and external services. Every control and architecture decision should trace back to a specific risk statement and residual risk acceptance. Control design is where governance becomes engineering reality. ISO 42001 expectations and risk assessment findings are translated into concrete controls that teams can build, operate, and prove. A control objective might become a model approval gate, prompt logging requirement, retrieval governance pattern, monitoring rule, or human review workflow. Each control should connect to an architecture pattern, an operating procedure, an owner, a frequency, and an evidence artifact. That makes controls reusable across projects, embedded in MLOps or LLMOps pipelines, and testable during design reviews and deployment approvals. Operational rollout is where governance becomes daily behavior. Controls are no longer documents waiting for audit. They are embedded in intake, risk assessment, architecture review, validation, approval, monitoring, change, and incident response. Each activity needs clear ownership: who is responsible, accountable, consulted, and informed across business, technology, risk, security, legal, and operations. Teams also need practical training on workflows, templates, evidence, and escalation paths. Finally, connect the controls to the tools people already use, so compliance is captured as work happens, not reconstructed afterwards. Certification readiness is proven through evidence, not by simply stating that the AMS exists. Auditors need to see that policies, risk assessments, architecture decisions, approvals, monitoring results, incidents, reviews, and corrective actions are actually operating. The evidence trail should connect each ISO IEC 42001 requirement to a control, an implementation artifact, a system record, and an accountable owner. Use a central repository or GRC tool to manage versions, status, review dates, and audit references. Collect evidence continuously, because audit preparation should confirm readiness, not create it. An AIMS program works only when governance connects to the people who fund, design, assure, and operate AI. Executives set the mandate, risk appetite, priorities, and accountability. Product teams and architects turn those expectations into designs, controls, and day-to-day delivery practices. Risk, security, privacy, legal, audit, and compliance teams test whether obligations are understood and evidence is reliable. Procurement, operations, and vendor managers extend the same expectations to third-party tools and support processes. Engagement must be continuous, because AI risk changes as systems move from idea to deployment and operation. Architecture-led adoption turns AIMS from a policy document into the way systems are designed. Enterprise standards create the baseline, so teams do not reinterpret requirements project by project. Reference architectures show approved ways to build governed data pipelines, model deployment, LLM applications, monitoring, security, and human oversight. Reusable patterns make controls easier to repeat, test, and audit. Architecture review boards then act as gates, especially for high-risk systems or major design changes. The result is faster delivery with less variation, because compliance is built into design choices before implementation begins. At certification readiness, the AIMS stops being a project and proves it works in practice. Start by confirming the evidence baseline: scope, governance, risk records, controls, and operating evidence. Internal audits then test conformity and effectiveness, not just document completeness. Any gaps become corrective actions with owners, deadlines, and verified closure. Management review brings leadership into the decision, evaluating performance, incidents, risks, objectives, audit results, resources, and improvement needs. Finally, assemble the certification audit package so the external auditor sees a controlled, reviewed, and improving system. The main takeaway is that AIMS implementation is a managed journey, not a paperwork exercise. Start with scope and risks. Design controls through architecture, engage the right stakeholders, and prove operation through evidence, audit, and review. From here, we go deeper into the documentation pack, maturity assessment, and audit preparation needed for certification readiness.